Hello everyone. Good morning. How are you? I hope you all are well. Before we discuss about this topic, let me introduce myself first. My name is Herfian Muhammad Nur Fattah Putra PSTI. Now I'm a first year student in Indonesia University of Education. Warm greetings to all of you. Okay, in this session, I invite all of you to get to know about quantum computer. There will be 4 points that we will discuss together about this topic. There are what is quantum computer, how it works, then what's the uses, and in the last point, we will find out what's the advantages and disadvantages of quantum computer. Okay, we enter into the first discussion. What is quantum computer? Have you ever heard quantum computer? When you hear the term computer, most of you will immediately imagine a device like a PC or laptop that is usually used for work, playing games, or watching videos on YouTube. However, what if you hear about quantum computer? There must be a lot of people who are confused because they don't know. So, what is meant by a quantum computer? Quantum computer is a calculating tool or computational tool that uses the principles of quantum mechanical phenomena such as superposition and entanglement to perform data operations. Quantum computing relates to computing made by a quantum computer compared to traditional computing done by a classical computer. A quantum computer should be able to store much more information and operate with more efficient algorithms. This translates to solving extremely complex tasks faster. But did you know what is superposition and entanglement in the principles of quantum computer? Superposition is the ability of a quantum system to be in several states at the same time until it is measured. In this case, qubits can represent many possible combinations of 1 and 0 simultaneously. To put the qubits into superposition, the researchers manipulate them using precision lasers or microwave beams. Given this counterintuitive phenomenon, a quantum computer with multiple qubits in superposition can solve a large number of potential outcomes simultaneously. The final result of the calculation appears only after the qubit is measured, which immediately causes its quantum state to collapse to 1 or 0. Then, what is entanglement? Quantum entanglement is a state in which two systems are so strongly correlated that obtaining all information about one system will provide direct information about the other, no matter how far apart the systems are. This entanglement is key to the power of quantum computers. The researchers were able to generate linked pairs of qubits, meaning two members of the pair exist in a single quantum state. Changing the state of one qubit will instantly change the state of the other in a predictable way. This can happen even if they are separated by great distances. In a conventional computer, doubling the number of bits means doubling the processing power. However, in the quantum realm, adding an extra qubit to a quantum machine results in an exponential increase in its number crunching ability. Until now, no one really knew for sure how or why this thread of entanglement works. Even an Einstein was also confused about this. Next, we enter into the second section in this topic, how it works. The field of quantum computing emerged in the 1980s. It was discovered that certain computational problems could be tackled more efficiently with quantum algorithms than with their classical counterparts. Quantum computing has the capability to shift through huge numbers of possibilities and extract potential solutions to complex problems and challenges. Where classical computers store information as bits with either 0 or 1s, quantum computers use qubits. Qubits carry information in a quantum state that engages 0 and 1 in a multidimensional way. But did you know what is qubits? So, qubits are quantum bits which are counterparts in quantum computing to binary digits or classical computing bits. Just as bits are the basic units of information in classical computer, qubits are the basic unit of information in quantum computers. Qubits have some unique quantum properties that are grouped, connected, and can provide far greater processing than the same number of binary bits. One of these properties is known as superposition, and the other property is known as entanglement. Next, in third section in this topic, what's the uses of quantum computer? There are many uses of quantum computers. In here, I will tell you 5 main uses of quantum computers. The first is a quantum simulation. Quantum computers are well suited for modeling other quantum systems because they use quantum phenomena for their calculation. Examples of quantum systems that can be modeled are photosynthesis, superconductivity, and the formation of complex molecules. Then the second is as optimization. Optimization is the process of finding the optimal solution for a particular problem. This helps experts and researchers find better ways to manage complex systems such as traffic flow, airplane gate allocation, packet distribution, and energy storage. Then the third is a searching. This dramatically speeds up searches of unstructured data and performs searches in fewer steps than traditional algorithms. Then the fourth is as cryptography. The RSA algorithm is widely used for secure data transmission and relies on complex problems such as integer factorization and discrete logarithms. Many of these problems can be solved more efficiently with quantum computers. And the last use of quantum computer is a quantum machine learning. Machine learning training models are computationally expensive. which has hindered the scale and development of this field. To accelerate progress in related fields, we need to find ways to design and implement quantum software that enables faster machine learning. Finally, the last section of this discussion around quantum computer was the advantages and disadvantages of quantum computer. Like all experimental technological developments, quantum computers have advantages and disadvantages that you should be aware of. The advantages of a quantum computer include: first, many applications can be developed in parallel. Second, it can perform millions of calculations infinitely and simultaneously. Third, in real life, quantum computers have many applications, especially in the field of medicine. Four, it's very important for the search and development of new clean and renewable energy source. Fifth, it's a key technology for machine learning and for the development of artificial intelligence. And the last six, due to their almost unlimited processing power, quantum computers are the key to optimizing the search and getting computational solution almost instantly. While some of the disadvantages of a quantum computer include: first, currently it has great difficulties at a technical level because a large number of qubits are required to process and correct errors. Second, it doesn't have sufficient hardware for so much processing power. The systems must be stable, and for this, the number of qubits must be increased. Third, they don't apply to ordinary users. That means they won't know what to do with a quantum computer. And the last, fourth, this is an experimental technology, and as of now, it's not feasible for massification. Many standard computers solve most problems more efficiently. Maybe this is enough for my explanation regarding the discussion about getting to know a quantum computer. The conclusion we can draw about quantum computer is that a quantum computer is a machine that uses the properties of quantum physics to store data and perform calculation. This new type of computing technology is extremely useful for certain tasks that far outperform even the best supercomputers. Okay, thank you so much and see you again.